DMX and ArtNet, and we give that laser context, obviously. I must admit, before I start, I'm not a lighting designer and I'm not an expert in DMX. But that's not what I want to talk about today, because I can't tell you guys how DMX works, because you all know much better than I how DMX can be controlled. But what I know is how we can do that with lasers, and how lasers can work in that context in a way that it's astonishing and that's emotionalizing, and how we can make that work like a normal lighting fixture, because that is what we experience a lot over the past years, that lighting designers want to use lasers like lighting fixtures. So let's have a look into that. But first of all, what is lighting control for us, and how do we deal with the different lighting control scenarios? There is various people doing lighting control in a more or less professional way. As you see, if you would do that with a laser, it would be very dangerous because it's handheld use. We don't do that. But that's a moving light, actually. Not the type of you want to get from us. That's also an alternative, how you can control lighting. It is a digital control, as you see, it's on-off. So digital, you would assume it would be very modern. No. And also, there is other options which probably are not really suitable with lasers. But yeah, you can also use normal light switches for moving lights. But this is all not what we're gonna talk about today. We're gonna talk about the professional approach to it. Now, if we talk about lighting and lasers, and especially the differences, we need to look a bit back in time, because historically we have a certain difference that used to be the problem for lighting designers to go into the laser world, because the control and the philosophy of control was so different. And that made it really difficult for lighting designers to adopt laser control, because there was always the requirement of difficult infrastructure. So we had this classic ILDA control signal with a bulky 25-pin connector. We sent rich data signal from a control software, so the device was super stupid. We just fired control signals towards the device. The projection is created dynamically. We had a really dense data stream, and we had content feeded in real time. Now, individual content required individual digital analog converters, and it was a lot of stuff that was going on that made it really difficult for lighting designers to actually adopt the use of lasers, because all that additional hardware, software, and wiring actually scared them off. So lasers always were special trade that was very specific. Now, some cheap lasers came in with DMX control a while ago, but that never really kicked off for several reasons, and it was really difficult, and that actually scared lighting designers even more, because it was difficult to use them and also dangerous at the same time. Now, looking at the lighting control side, we had built-in functionality into the lighting devices. We had light-wide control options. We had light-wide connectivity. We just have trigger signals. But also, we are stuck with built-in hardware. Challenge always is, with a conventional lighting system, we have built-in hardware, and you can't change that. So if there's a certain gobo, there is a certain gobo, but you can't change it. That always was an advantage of laser over lighting, because we could actively change the content and real-time change the content. Now, for lighting, a low-level control signal always was sufficient. We didn't have any rich data, and the devices could easily be addressed. And this is something that was crucial for the type of productions we see nowadays, with multiples, like hundreds and thousands of lighting fixtures on stage. It wouldn't be possible to control them all with rich data. Can you imagine having 1,000 moving heads on stage and sending rich data to all of them? That would clog any network. It would be crazy. That's why the trigger control definitely makes sense for that kind of multi-device setups. Historically, spoken about laser shows, this is a typical example how the shows looked back in the day. I mean, back in my days. I mean, there was much backer days for others amongst us probably where laser shows even look different than that. But this is the typical scenario. People sitting there waiting for the music play, and there is a synchronized show to the music. Everybody is applauding afterwards, and that was the laser show. So that is the typical historic approach to a laser show. People sitting there waiting for it, happening, gone. This has changed a lot over the past years. We still see these kind of laser shows, but laser shows become more and more integrated to multimedia productions. They become an integrated part and are not used as solitary effects anymore. You have lighting systems that are synchronized. You can easily combine them. You can easily synchronize them. You just have that built-in hardware, and that can be triggered and that can work. And you can synchronize movement, you can synchronize behavior over many fixtures. Now this is a huge advantage over trigger control. Trigger control, like with DMX and ArtNet, allows you to use a multitude of fixtures and apply effects over these fixtures as a unity of devices. And that is a huge advantage because you can make a good number of fixtures look as if they play together. It's not that single device anymore that is in front and people look towards that laser show and expect like a 3 or 5 laser show happening. It's like a unity of effects that play well together. What we can do with the lighting desks is we can apply phase shift movements, intensity chases, color fadings all over all devices. We can do wave effects, and we can orchestrate movements and create effects that emphasize this unity of similar devices, basically. Like we have that with moving lights for many years already. Laser systems can do this too. There was the first approach to this, pretty much, I don't know exactly when this was, but we started this project in, I think it was 2016 or so, maybe even 15, the first laser bars with scanning systems. And the idea behind was exactly that, kind of orchestrating an output in a way that you have synchronized movements and create effects like that. You create effects in mid-air. You have basically 5 dimensions with these that you can control, and the effects are astonishing in the room. This video was done with the first, well, the products in this video are the first Neo 6 that we used in those days, and that was the first product that we brought out with the scanning capability, and that was basically a milestone with getting the DMX control to a professional level for a multitude of fixtures. Now, these still were the beginning, and the whole control technology and control options have evolved after that. So lasers used to be solitary effects, but now they're often used as a unity of many devices. But what makes lasers different to conventional lighting fixtures? And this is something that scared off people in the past of using lasers, because they were scared of the fact that there is a potential risk. But, I mean, there is a potential risk. It's all a matter of how you deal with lasers, how you treat them. There's also a potential risk in driving a car or handling a chainsaw. The question is what you do with it, and if you have the correct tools of dealing with a risk. Because obviously, there's also risks with conventional lighting. I mean, all lighting fixtures in risk group 3 have certain minimum distances that are required for them to be safe for the human eye if you focus the beam. So that not only applies to laser fixtures, but also to conventional lighting. So that risk is imminent on different levels. It's just a matter of how you deal with it. And in the laser industry, we are aware of the risks, and we also know how to deal with these risks and find solutions to minimize the risks. And this is exactly what we worked on. It is essential to always make sure that the lasers do not exceed the maximum permissible exposure in the audience area. Now, if you tell something like that to a lighting designer, they don't understand what this is about. I mean, we have lighting designers amongst us. You probably have that laser background, so for you it's all cool. You understand that. But this can be frightening. Actually, it's not a big deal if you know how to handle the situation. And there is actually two ways. We can reduce the power to a level that the MPE is not exceeded. So if we hit the audience, we can reduce the power in a way that there is no harm. But why do that at all? We can also avoid hitting the audience, and then we are pretty good. And there is ways of doing that. And this is something that we need to consider for DMX and ArtNet. Control, only the option 2 should be relevant, because this is how we can control how the beam is handled and that the risk can be controlled. Because everything else requires software control to really be able to maintain a certain safety level. But remembering this makes it super easy, because we can say, hey, well, we stay overhead and we're good. The question is, how can we do that with DMX? Because DMX, technically, I speak of DMX and ArtNet in the same way, because they're pretty much the same thing. The one is on a network basis, the other one not. But it's pretty much the same thing. How can we do that? Safety is a thing with DMX, because DMX itself is not a fail-safe protocol. This is no problem with moving lights, because if there is a glitch on DMX and the moving light doesn't move as it should, not too big of a problem in most cases. With a laser, that can be a problem, and we need to consider this. What happens if an operator of a laser system hits full on or locate on the desk? Can the laser get out of that designated area? Can somebody be irradiated in a way that is not intended? So the control safety that we put in there cannot be the DMX desk, because limiting the stuff on the DMX desk itself is not sufficient, because that can fail, because DMX is just a trigger. If there's the wrong trigger signal coming in, there can be laser radiation out of the zone that we want to have. So for lighting designers, this is a turn off, because they can't do it. They don't want to be faced with that challenge. There is solutions to this. And there is two solutions, basically, two main scenarios. There's a bit more options, but there is mainly two scenarios. We have a computer in the middle. So we have a lighting desk, we have a computer with control software, laser control software, basically, and we trigger that software, and that software controls the output content, and the output content is then sent in real-time data to the laser, so the laser can output it. Doesn't matter if that's ILDA or LAN or whatever. It's a matter of the software. So the software is triggered, and the software then handles all the safety aspects of the laser. This is one scenario. And the other scenario is you directly connect to the main board, and the main board of each device handles the safety. This, of course, requires less infrastructure. It has its downsides in terms of detail settings. But thinking about a multitude of laser, not thinking about 10 lasers. Let's think about 200 lasers, or think about 1,000 lasers, or 2,000 lasers. Option 1 would be a nightmare to set up, because to get the infrastructure with a control computer that is remotely controlled and then sending the signal out requires a lot of overhead, hardware, and infrastructure. Whereas option 2 gives you more flexibility, because all the handling of the safety as well as the handling of the content happens inside the device. And if you have such a multitude of laser systems, it's also not that important that you have like a little bit of 0.1 degree rotation option somewhere. Well, we still have that in the devices, but some very dedicated control of each system, because you can't even control each system individually, because just setting up 2,000 lasers would be a nightmare. It would take you days for just do the zoning and all this. So, as we see that tend towards more lasers at productions, we saw the challenge that people may come across when doing that on site, when having to deal with that amount of systems on site. Sorry, there's an animation glitch. We do it like that. So, speaking from a safety side, we have 3 options to add safety. Control side, we mainly have 2. From a safety side, we have another one, which is hardware beam blocks. So we can put like beam blocks in front, some metal sheet in front that blocks radiation from the audience. And this is always something that you can do, or you should do, in addition to any setting you do, any software setting, any mainboard settings, because obviously that makes sense. But just relying on that, or just even probably using that for cutting off certain parts of a projection, that doesn't work well. Because if you have a projection and you have a metal sheet in front that blocks part of the projection, you have a chromatic aberration, and part of that light gets bended, and you see a very nasty fade-out effect, which is also quite random, because you're very close with that metal sheet to the output, and that doesn't allow for really fine adjustment of that metal sheet. So it's always a thing of the last resort that you avoid having something glitch. But for a general projection limitation, it's really difficult. Software side projection requires software, computer in between the DMX control and laser system, and you require software skills and potentially licenses. But obviously it is more distinctive in what you can do. But the hardware infrastructure, the more lasers you get, the hardware infrastructure gets more complicated to handle. If you do the settings in the laser mainboard, that gives you more opportunities, because having that in the mainboard allows you to directly trigger that mainboard, and each product is individual. So each device is an individual lighting fixture, like a moving light. There is no additional device outside of it. You just connect your DMX cable like you would do with a moving light, and that's it. All the content, all the intelligence is inside the device. Let's look at a software thing. You can kind of zone stuff in softwares. You can do that individually per output. You can do fine adjustments. You can do settings for camera positions that you want to black out. And there's many scenarios that require these kind of settings, because you need to have distinctive control. But in most cases, those are scenarios with like 10 lasers, maybe 20 lasers, maybe 30 lasers. But what I'm talking about is more. And this is what we see more and more on stage. And we also see that today here in the room. Maybe we can fire up the S12, the RTI Neo S12. Can we just fire them up? So these are the RTI Neo S12. And maybe we can show some stuff, them playing together. So these are individual outputs, each controlled by DMX individually. There is no computer in between, that's just the main board playing, and you can really get these kind of effects synchronized. Maybe we can just dim down the front light a bit. And a bit more haze maybe, and then we try it later again, because a little bit more haze doesn't do any harm, I think. Ah, no, it's fine. It's fine, it's fine. So, it's a rather easy setup with 6x6 laser outlets, just controlled individually by DMX. No software involved. Now, this is what we have in these RTI Neo 6. This is the ShowNet mainboard as the main control mainboard in these. So each outlet has an individual mainboard. And this mainboard is just not a normal mainboard. It's not just a DAC where you have digital analog converter like with a classic laser system. It is also not just a playback system as you know it. It is more. As you can see here, we have an API where the software can directly access it, but that's what I talked about in the previous presentation. What I want to emphasize is having these features here, DMX out, DMX in, and ArtNet. What we can do is we can directly trigger the content inside these main boards by DMX and ArtNet. Now this alone probably is not that surprising and not that fancy, because there is other mainboards out there that can do the same thing. You can trigger content on the mainboard. And that is cool, because triggering content on the mainboard allows you to store the content inside. You can control a multitude of lasers, like hundreds and thousands of lasers, and you can control them and trigger them individually. But there is another challenge, and that lets me get back to the safety aspect. Because it's nice to have the content in there, but the question is, how can we do that in a safe way? Now we learned we can do it with software, we can do the zoning, and you can also use DMX controller and adjust the size of the projection. But as I said previously, DMX is not a safe protocol. There can be glitches, there can also be operator errors saying full on or locate, and then everything you did on your console is irrelevant because the beam wanders out of the projection area you set. Because that is just something that you set in your console, and it's not something that is inside your laser. Now there is the challenge, because how do I get the safety aspect into the mainboard without having to use a computer control or any computer at all? And this is what the ShowNet mainboard can do. And this is a huge advantage of the ShowNet mainboard. It's the only mainboard that can do this. We can set this mainboard to a so-called setup mode. And that allows the mainboard to be configured in a way that you can set settings in a way just with your lighting console, and you can then store these settings back into the mainboard, so they are stored inside the mainboard, and everything you do afterwards is inside these settings. This is a little software tool that can do the same thing, that actually visualizes what is set inside the laser. But everything we can do here, we can do with just DMX and ArtNet. We don't need any computer on the production side for it. If the lasers are set to DMX or ArtNet mode properly before, you just show up at the site, you use your lighting desk, you select all outlets at once, and you make save, and all of them are set to a projection zone, and each one of them has them saved inside the main board, and you can play afterwards and you don't have to worry about it. How do we do that? Let me show you with something that you probably know much better than I do, but I pull it up anyway. This is my little Grandma on PC. It's Grandma 2 because I don't know Grandma 3 yet, or not that good, and I don't want to be blamed for not knowing what I'm doing. I just have very basic skills of this, but it's sufficient to show you what's going on. I have this little laser here with me, and I can just switch it on, and I get some output here. I don't know if you see it properly, but I can turn it a bit so you can see we have this output. I don't turn it on to the full because we might damage the LED screen and I don't want to pay for it. So just keep it at 50%. Now what I can do is I use a gobo, and there is a so-called test grid built into each laser system with ShowNet. And you see there is preview pictures like the gobos of the laser, and on 255 there is a test grid. And we get this test grid, and with this test grid we can do some alignment work, because this is the full span of the projection area, and with using the test grid it is super easy to actually adjust the projection zone or even apply safe areas. Now what we're gonna do is we don't work in that live mode now. We switch that laser system to the setup mode. Let me explain how that works. We have two DMX channels, two specific DMX channels, and on these two channels we have two specific values which are not the same on both. And if we hit those two specific values, the main board knows that it now should switch the whole DMX layer to a second layer. So by doing that, we switch to that setup mode layer, and everything we then align will be saved later when we hit two other specific values on these two channels. And this is how it works. Let me show that to you. I just have to pull up the DMX sheet because I don't know the specific values by heart. I used to do when I did the design for this, but that's a while ago. Let me see where the DMX chart is. Don't have it here, so we pull it up here. There we go. Sorry. Probably good for you to see anyway how that looks. So you see here on the second page it's mode select, and that's also the same on the profile. Mode select 1, mode select 2, and we have the setup mode with specific settings. So we have 134 and 49. Just pull that to the other side here. So we go control, mode select 1, and here we have that preset in that profile already. So what we do is setup mode on this one, and then we have 20 seconds to select setup mode here as well. And now you see this starts flashing. And when you see that flashing, it indicates that it's in setup mode. So you see you're not in live mode, you're in setup mode. Now, what I can do is I can change the size. So I do size Y and reduce the size. So I reduce the size on the Y-axis. And I can reduce the size on the X-axis as well. And I can also shift it with a position. I can do positioning here on the Y position, for example. I can shift it higher up. And I can also do some sort of, it's not like super big geometric correction, but it's some sort of geometric correction that I can apply. You see that? And I can do certain kind of basic geometric corrections, which you normally don't necessarily need to do, because in most scenarios where you have like thousands of lasers, you don't have a geometric correction requirement. What you simply need to do is keep the lasers overhead. We could do some safe zoning on here, so we could do some intensity reduced area with beam attenuation in a certain area. That is possible, just on the lower end, upper side, left or right, we can have that. So this is possible, but it's not necessary. But I can pull that up. So if we do the, just for us to see it, I reduce that and the size of the safety zone. So it's coming in from the top, and I don't know if you see it. It's now full, and then we get it, it should come down from the bottom. Let's see that. Yeah, now it's half. I just reduced that further. And you see it reduces the lower end of the projection in intensity. Can you see that? So this lower part is less intense than the upper part. So that's also possible. And if we now want to save that, I just reset this because we don't need it. If I want to save these settings, I simply set this to save settings and this to save settings. I again have 20 seconds. And now it flashes 3 times and the settings are applied. You can also see that we don't have any flashing anymore, and the settings now are applied double because they are stored inside the main board, and we still have our DMX settings applied now that double up. So if I reset all settings and I pull up the dimmer to 50%, and I select my gobo, I'm in the zone. And everything we do with that laser now is in that zone. It doesn't matter if it's computer control, it doesn't matter if we do automatic operation on the laser, it all stays in that zone. So we could even now switch that laser to automatic operation, because we can do that with this laser, automatic operation, and it stays in that zone. We can even switch it off and switch it on, and the automatic operation will stay in that area. And this is the thing. Can you imagine how much that eases the process of setting up thousands of lasers by just making it safe in a very convenient and easy way? This is what is the advantage of the ShowNet mainboard if it comes to control in a professional way with DMX. Let's have a closer look on little bit more features, not too many, just to make a good finish to the presentation, because some things are pretty neat and pretty decent with this mainboard as well. For example, we have the ShowNet mainboard also available in ArtNet. We can connect to it with ArtNet, and we can also do some stuff with ArtNet with that mainboard. So for example, if you also use that mainboard in a smaller setting, where you have a wedding and you want to have the fog machine controlled, then you can simply use your laser, you get the control signal by ArtNet, and you can get DMX out of it because it's an ArtNet node, if you want to make it ArtNet node, you can simply connect your fork machine with a small, short DMX cable and just place it underneath your lasers. That is also possible. So this is one nice feature, but of course you can directly control the lasers with ArtNet as well. You see, you can switch to ArtNet here, and then it adopts the ArtNet. And it's a bit longer text, but just for you to understand how it works, the ArtNet mode is very intelligent on this device, because it automatically adopts the correct address and then becomes available on the net without having to use RDM or additional features. Why don't we have that in there? Because that device should also work for people that don't have these sophisticated features in their controllers. Because we could have solved certain things with RDM or SACN, but we wanted to have the control option, especially on the safety side, as easily accessible for people as possible. That's why we made that double layer DMX, to make it as easy as possible to access safety for everybody. So this is what I already showed you, so we don't need to watch the video, because we saw that in live here with the Grand MA, the control. Obviously that works with any other lighting desk. Back there we have a Jamsys, works like a charm as well. Yeah, if you want to experience that yourself, want to try it out, you can come here and play a bit with a console, no problem. I can put the laser there so you can have a look, because the program for today, the workshops and presentations, are finished with this presentation. And first of all, thank you everybody for attending and for coming here today. And we will continue with a barbecue. It's basically down alongside the building, and around the corner there is also a map available in the entrance area where you find the barbecue. We will have food there, and afterwards we head down to the basement, and we will do some open laser things. So there will be lasers, there will be computers, there will be people with laser shows that play laser shows. If you have laser shows, you can play your laser shows. If you want to play with lasers, want to experience certain controls, want to experience certain setups, feel free to join in. There will be several smaller groups, most probably, that just play at different settings. We will have DMX control, most probably. We will have the latest version of Show Controller there, with a preview glimpse on Show Controller Ultra, with AVB output and AIF support, AIF file import and export, and direct connection to all laser animation devices through AVB. So this will be a preview down there, and we will see some features on the AVB side, so there will be some AVB playing as well, and we will see some nice laser shows. As far as I heard, we have, I think Jörg brought some nice graphics stuff that he did recently, so that will be nice. And there will be drinks, and we have food outside, so yeah, everybody enjoy the evening then. And yeah, if you have any questions, I'll be around. Ask me anything, and yeah, then see you tomorrow for the Innovations Day. Thank you very much.